In this video, we're going to be talking about Hess's law. So the first question is we need to ask is, what is Hess's law? Hess's law is the sum of enthalpies through a set of reactions. If you look below down here, you will see a set of reactions shown by this arrow. So this is what we're talking about. Hess's law is also a state function. Recall that a state function is not dependent on how you obtain the value through measurement. It's the end measurement that counts. So we were wanting to go to travel from A to B. There are many different ways to get to B. The end result is you guys still end up at B, which is what counts. Now Hess's law is a puzzle, and puzzles can be worked different ways. And that's how we're going to approach this. So the way that I do it may not be the same way that you do it, but in the end you'll yield the same result. That's the goal. So for this particular topic, Hess's law again deals with enthalpy of a reaction. So we're going to be solving for delta H of a reaction. So to do this, we're going to be using these individual steps that you find here. So as I start to work a problem like this, what I do is I pay attention to the reactants first, and I'm going to pay attention to the very first reactant, NH3, and I look at the equations below and I find that NH3 is found in the second reaction. The problem is that NH3 is a product in that particular set, and that's in the main reaction, which is found in blue. NH3 is a reactant. So what we're going to do is we're going to flip the equation there. So we're going to take the second step there and we're going to flip it. We're going to make NH3 be a reactant. It's going to produce nitrogen gas plus hydrogen gas. Now we're going to keep track of the delta H values, and so when you flip the reactions around, you also need to pay attention to the sign. You're going to flip the sign. So since delta H is negative 91.8 and we flip it, well, the negative turns into a positive at that point. Now if we also pay attention to the coefficients in the balanced equation, we will see that there's a 4 in front of NH3, but then if you look at this step 2, there's 2 NH3s. So what we're going to do is we're going to multiply this step by 2. And so whatever you do to this step, you also have to do it to the enthalpy, your delta H. So that's the first thing I do, is I want to go ahead and focus on getting the NH3 into place. So the next thing I'll do is I'll look at the other parts, and I'll find that there's an NO as a first product to this reaction. And I'll look at the first step and I find NO is a product. So that's already in a good place. So what we want to do is we're going to set it up here, and we're going to have N2 plus O2 yields 2NO. And the delta H for that was 180.6 kilojoules. Now I want to look at the balanced equation. There are 4 NOs, but in the step there's only 2, so we're going to do the same thing we did in the first step, and we're going to multiply by 2, and we do the same thing for delta H. Now the last step is, which there's only one more step. We see that there's water. If we look at the main reaction, water is a product, and so we want to make sure that the waters are introduced into the equation as a product. So we're going to write the equation as we see it. So you have 2 hydrogen gas plus oxygen gas yields 2H2O gas. So going back to the equation, we see that there are 6 waters, but in the step 3 there's only 2 waters. So we're going to multiply that by 3, and we're going to carry that over. We didn't flip anything, so it stays negative 483.7. So that's pretty much all the steps. Now what we're going to do is we're going to combine the steps and cancel out like terms. And math-wise, we're just going to follow what Hess's law says and states, is it's the sum of the enthalpies. So we're going to take these three different things and we're going to add them together. So we're going to have 2 times 91 plus 2 times 180.6 plus 3 times negative 483.7. And we end up with negative 907.9 kilojoules. So that's taking care of the math part, but we also want to take care of the simplification, because we want to make sure that our overall equation is the same as what the blue equation is. So we're trying to match this equation here. So we see that we have 4 NH3s. So distribute throughout the parentheses. We have 4 NH3s. We're going to have 2 N2s and 6 H2s. Now I'm not going to carry those down because I'm going to look at the next step and I find that there are 2 N2s here, because you're going to distribute it yet again. So the N2s are on opposite sides, they're going to cancel out. And if you look at the hydrogens, we have 6 hydrogens here, and we're going to have 6 hydrogens on the opposite side, so the hydrogens are going to cancel as well. Now, if we pay attention to the oxygens, we have 2 oxygens here, and then you have 3 oxygens here. So 2 plus 3 gives me 5 oxygens. There are no oxygens on the product side, so they're not going to cancel out. And we're going to yield 4 NO plus 6 H2O. So we're going to compare this to what we have over here. So we have 4 NH3, good. We have 5 O2, that's good. 4 NOs, and then 6 H2Os. So with that being the case, our simplification worked out. The way we set up the equations and the steps were fine. As long as we did okay with the math part and plugging it in the calculator, we should be fine. So that means the delta H for this reaction is equal to negative 907.9 kilojoules. So what's the negative sign mean again? The negative sign tells you that the reaction is exothermic and it's losing that much energy overall. In the second problem, we're going to repeat the same process as we did in the first example with the NH3 plus oxygen gas. In this one, we have C2H4 reacting with hydrogen gas to produce C2H6, and there are 3 different sets of reactions here that we're going to use to determine the delta H reaction for this overall reaction. So just like before, we're going to pick something to start with, and so I always start with the first reactant, in this case C2H4, and I see that the first step has that in it, so I'm going to carry that down. So C2H4 plus 3O2 yields 2CO2 plus 2H2O. Delta H will be tabulated to go along with this. This is negative 1401 kilojoules. So looking at the equation at the top, there's one C2H4. In this equation, there's only one, so we don't need to do any multiplication as of right now. So we're just going to keep it the way it's wrote. So then we're going to look at the second step, and we see that C2H6 is a reactant, but if you look in the overall step up top, C2H6 is a product. So we want to reverse this equation around. So I'm going to flip it. So we're going to do C2CO2 plus 3H2O yields C2H6 plus 7/2 oxygen. Now you can write 7/2 oxygen a different way if you want, if you're not comfortable with the fraction. So 7 divided by 2 gives me 3.5. So I'm going to write that below here. So 3.5 is the product of that. Now, if you pay attention to the sign, delta H is negative 1550 kilojoules in that step. Since we reversed it, we don't need to carry down the negative sign, which it's just going to be positive 1550 kilojoules. So that's what I've talked about earlier. Last step here is we look and see that there's one more reactant left, and that's hydrogen gas. Hydrogen gas is a reactant in the third step, so we're going to keep that as it is, and we're going to carry it down. And there's only 1 mole hydrogen gas in both this step and the overall, so we don't need to multiply by anything there, and carry down to negative 286. So we're at a point now where we can start simplifying, canceling out terms that are the same. So let's do that. So C2H4 gets brought down. That's not going to cancel anything. We look at the oxygen here. We have 3 oxygens here, plus the 3 oxygens here, plus the half oxygen. That's 3.5. So we look on the right hand side, those oxygens are going to cancel with the 7/2. So the oxygens are gone. Now let's look at the CO2s. Alright, we have 2 CO2s here and 2 here. CO2 is going to cancel. And if we look at the waters, we have two waters here and a water here. So 2 plus 1 gives me 3. That's going to cancel out with the 3 waters. So that leaves me with hydrogen gas and C2H6. So hydrogen gas is going to come down as a reactant, and it's going to yield C2H6. So if we look at this equation here, this matches what we have in the overall equation. So now, as we talked about earlier, you're just going to sum these 3 different things together. So we're going to have negative 1401 plus 1550 plus negative 286. That gives me negative 137 kilojoules. And again, this represents delta H for the reaction. Since this reaction symbol is negative, that means that this reaction would be exothermic. In the third problem, we're going to be looking at a reaction. We're going to take 2 carbon solid reacting with hydrogen gas to yield C2H2 gas using the steps below. So we're going to calculate again the delta H of reaction for using these steps in Hess's law. So just like I started with the previous 2 problems, we're going to start with carbon solid, and we're going to see that carbon solid and then the second step. So I'm going to go ahead and bring that down here. Delta H for that is negative 394. We don't need to reverse it because carbon's in the right place. But we do see that in the overall equation there are are 2 carbons. So we're going to multiply this by 2 here. Now, as we look at the first step, we see that it has C2H2 as a reactant, but in the overall step, we need the C2H2 to be a product. So we're going to flip that equation around. So we're going to have 2 CO2 plus H2O yields C2H2 plus 5/2 oxygen. Now 5/2 is really 2.5, so you can write that below if that makes it easier for you. We don't need to multiply by anything because we have the right number of C2H2s, but what we do need to do is change the sign from negative 1300 to positive 1300 kilojoules. So there's one more step we can use, and that is the last step. If we pay attention to the overall equation, we have hydrogen gas left, and in that last step, hydrogen gas is the first reactant, so we are going to keep that with it. We have half oxygen yields H2O liquid. And we don't need to multiply by anything because hydrogen gas has the right number of molecules present. It's a balanced equation. And we didn't reverse it, so we're going to carry down to negative 286 kilojoules as you see it written. Now we're going to go ahead and go through the simplification process like we saw before. And just don't forget to distribute through the parentheses here. So we have 2 carbon solid. We have 2 oxygens on this side. Then we have the half oxygen. So 2 goes here. We have the half oxygen here. So that's 2.5 oxygens. Over here on the right side, we see that that's going to cancel out. So oxygens are gone. And then if we look at the CO2s, we have 2 going to the CO2 over here. So you have 2 CO2s on the right hand side, 2 on the left, so the CO2s are going to cancel. And then let's look at the waters here. We have 1 here and 1 here. That's going to cancel. So we just carry everything else down. We see that hydrogen gas is here, so we're going to bring it down as a reactant, yielding the C2H2, which is left over here, and that's a gas. So this is our overall equation. Look up top, it matches it, so that's good. So all we need to do now is carry down the math here. So again, just use Hess's law, which is the sum of the enthalpies. So 2 times negative 394 plus 1300 plus negative 286 gives me 226 kilojoules of energy, which is equal to the delta H of this reaction. A little different from the last two because the delta H here was positive, which means that this reaction is endothermic. I hope this tutorial has helped you with Hess's law. The more practice you do with these, the better you're going to get. So use your textbooks, worksheets that you have online, whatever it is that you have available, use it, practice it, and get better with it. Remember, Hess's law is just a sum. It's a puzzle. Put it together. You can do it several different ways. My way, I've always done it this way, but you might find a better way. But in the end, it's all about what you get for delta H. If your answer matches my answer, then that way is perfectly fine. Just make sure that the overall equation also matches what you come up with in the steps. Alright, thanks.